All right, so remember, when we are graphing, find the y things first, then the whole, then the x things. And so starting with the y things, we're finding the y-intercept and the horizontal asymptote. So horizontal asymptote is HA. So HA, funny acronym. We have a degree 1 over a degree 2. So it's bigger on bottom. So y equals 0. Okay, so we can draw in the horizontal asymptote at y equals 0. Next, we're going to find the y-intercept. This is where we plug in 0 for all the x's. And so if I plug in 0 for these x's, I'm left with a -5 over a -25, which simplifies to positive 1/5. And so my y-intercept is 0, 1/5. Remember, this is an equation. This is an ordered pair. And so for my y-intercept, it's just slightly above 0 at 1/5. And so I'm just going to put it right there. Okay, and so do not find this vertical asymptote or x-intercept until you simplify and find any common factors. So we're going to see if there's a whole by simplifying this. Okay, so the top 2x minus 5, that's already linear, and there is no GCF. So I'm going to put it in parentheses. That's one factor. Okay, on bottom, that's a difference of squares. 4 and 25 are perfect squares. There's a minus sign in between. And so this factors 2x minus 5 and 2x plus 5. Okay, and so I do have a common factor. 2x minus 5 and 2x minus 5 are in common. And so this simplifies. There's nothing left on top, so just a 1. And then a 2x plus 5 on bottom. So there's our simplified form. Okay, you're never going to go back to this equation. You're done with it. You're going to be working with the simplified form for the rest of this information. Okay, I always like to cross it off so you don't accidentally set this denominator equal to 0. You're only going to be setting this denominator equal to 0 to find your vertical asymptote. Okay, and so now that we know there's a common factor, take the factor that you crossed off. Okay, as soon as you cross it off, find the x-coordinate of the whole. Okay, by setting that exact factor, the one you crossed off, set that one equal to 0. Don't set the remaining one equal to 0. Okay, so add 5 to both sides, divide by 2. And so that is the x-coordinate of the whole. And then we take that, and this is where a lot of people get confused. You take that and plug it into this simplified form to find the y value. Okay, and so y equals 1 over 2x plus 5 from that formula right there. And we're going to plug in 5 halves. 2 times 5 halves is just 5. And so we end up with 1/10 as our y coordinate. And so 5 halves, 1/10 is the coordinates for the hole in the graph. Okay, so you're going to go to those coordinates. 5 halves is the same as 2.5. So right here. And then 1/10, it's smaller than this y-intercept at 1/5. And so put an open circle really close to 0. Okay, there's the hole. That's how you plot a hole, just like a point, but it's an open circle. Now that you've done that, you are ready to find the x things, meaning the vertical asymptote and the x-intercept. And so for the vertical asymptote, we set the bottom equal to 0. Okay, and so for the vertical asymptote, we're setting 2x plus 5 equal to 0. And so subtract 5 from both sides and then divide by 2. we get negative 5/2. And there's only one vertical asymptote. Don't tell me there's one at 5/2. That's where the hole was. You can't have a hole and a vertical asymptote at the exact same spot. I've seen a lot of people try to graph a vertical asymptote right through a hole. That doesn't happen. That's why we only work with this one to find the vertical asymptote. Okay? And then for the x-intercept, we set the top equal to 0, which is just a 1. We don't have this factor anymore, just a 1. And so when you set that equal to 0, that never happens. 1 never equals 0. And so the x-intercept does not exist. And that's because we have a horizontal asymptote that we've never crossed. Okay, so anytime you have a horizontal asymptote, sometimes you might have an x-intercept in those weird situations, but usually you won't. So it's okay to have an x-intercept not exist. What's not okay is don't set this factor equal to 0. You crossed it off. Okay, so no x-intercept to graph, but we can graph our vertical asymptote at negative 2.5. Oops. Okay, so there's our vertical asymptote. Okay, and so when we're graphing the rest of this, the hole acts like a point that you can graph. And so I know that we're going through this y-intercept, don't cross the vertical asymptote, and then we're going through the hole, but don't cross the green, the horizontal asymptote. So one of my branches looks like that. Okay, I know there's more function over here. I don't know if it's up in this quadrant or this quadrant, so we need to point test. And so let's plug in -3. You could plug in -4, -5. I like to plug in as close to the asymptote as I can because then the number is smaller. And so again, we're working with the simplified form. And so we're going to plug in x equals -3. And again, I just chose that because it's to the left of the asymptote. 2 times -3 plus 5 on bottom gives me -6 plus 5, which is -1. So -1. So we have a point -3, -1 right here. And so I know the rest of the graph follows the green asymptote from below and the red asymptote here. Okay. And so for the domain, there's still 2 domain restrictions. One happens to be a hole, one happens to be a vertical asymptote. Okay, and so we still have to exclude both values. And so x cannot equal 5/2, and it cannot equal -5/2. This is the vertical asymptote. This is the hole. So just like we did at the very beginning of this unit, you always set the bottom equal to 0. Regardless of what kind of restriction it is, it's still a domain restriction. And so in interval notation, we would have -∞ to -5/2. That's this branch right here. Union, pick back up at the -5/2. And then you have to skip over the hole as well. So stop at +5/2, pick back up. So we still have to exclude those 2 values, writing it this way. Okay, so that's example 1. Example 2. Okay, before you factor, before you simplify, before you do anything, we're going to find the y things first. So starting with the ha-ha, funny acronym, we have a quadratic degree 2 over degree 1, so we're bigger on top. That means it does not exist. No horizontal asymptotes to graph. Okay, for the y-intercept, we plug in 0 for x. So all these x's on top disappear, giving me a -1. And then on bottom, this x disappears, giving me a +1. And so that simplifies to -1 for the y-intercept. So that's an ordered pair, 0, -1. And we can graph it right there. Okay, y things are done. We are ready to simplify. And so we need to factor this 2x squared plus x minus 1. We can't use the shortcut because a isn't 1. So a times c is -2. Add to 1. That would be 2 and -1. So split the middle. So 2x squared plus 2x minus 1x minus 1. Factor a 2x. Factor out a -1. And so x plus 1 is one of our factors. 2x minus 1 is the other. Okay, so the new numerator, not new, but the factored form of it. And then on bottom, we have an x plus 1. Okay, so we do have a common factor, x plus 1, x plus 1. And so we know there is a hole in the graph where x plus 1 equals 0. Whatever you cross off, that's what you set equal to 0. Subtract 1 from both sides. That gives you the x coordinate of the hole at -1. Okay, now we're only left with a 2x minus 1 on top and a 1 on bottom. You don't have to write 1s on bottom. And so it's just 2x minus 1, which is a linear function. And I'm actually going to show that to you on the graph in just a second. Okay, and so our simplified form, get rid of this, never look at this again, is 2x minus 1. So we have to plug that x value in to figure out the y coordinate of the hole. So 2x minus 1 coming from there, and we're plugging in -1, gives us -2 minus 1, which is -3. Okay, so the hole is at -1, -3. So -1, -3 has an open circle. All right, hole is done. Now we are ready to find the x things. Okay, so to find the vertical asymptote, we set the bottom equal to 0. And so the bottom is just a 1. And when you set that equal to 0, that never happens. And so our vertical asymptote also doesn't exist. Okay, that's because this is looking like a line. And so we don't have any asymptotes. For the x-intercept, we set the top equal to 0, which is the 2x minus 1. Add the 1, divide by 2. So 1/2 is our x-intercept. So right there. Okay, so we have 3 points here, and this is forming a line with a y-intercept of -1, and then a slope of 2. Rise 2, run 1. So rise 2, run 1, rise 2, run 1, rise 2, run 1. And you can plug in all these points and actually get these y values from that equation. And so it looks just like a line, only there's a hole in the graph. Oh, I'm doing terrible here. Okay. Looks linear, only there's a hole in the graph. Okay, and so when we are talking about domain, the domain is all real numbers except where the hole is. That's our only restriction because there's only one number on bottom or one factor. And so all real numbers except x cannot equal that -1. And so in interval notation, looks like that. Okay, so I just want to show you in your calculator that this does look like a line. And so if I were to graph the original function, which was 2x squared, so you can get a fraction by doing alpha y equals, the green button, alpha y equals, and then choose option 1. Okay, and so in the numerator, we had 2x squared plus x minus 1. And then in the denominator, we had x plus 1. Okay, so in y1, I'm going to graph the original function. And then in y2, I'm going to graph the simplified 2x minus 1, that line. Okay, and so when I graph it, there's the original. That rational function looks just like a line. And then in y2, the exact same line. They're right on top of each other. And so if you go to the table, that's where you're going to see the difference. They have all the same points. Look, the blue and the red have the exact same y values for these x's, except when you get to -1. y1 has an error because there's a hole there. Okay, so sometimes rational functions can look like lines with a hole in the graph. Okay, example 3. Okay, so don't factor, don't simplify, find your y things first, starting with the horizontal asymptote. We have degree 2 over degree 3. Hopefully you can see that better on your own paper. So we're bigger on bottom. So y equals 0. Horizontal asymptote at y equals 0. Okay, the y-intercept, if you plug in 0 for x, you get a -1 on top. If you plug in 0 for x on bottom, everything disappears to 0. That's error. And so the y-intercept does not exist. Anytime you get 0 on bottom, error. No y-intercept. Okay, we are ready to simplify. So the top is a difference of squares, x plus 1, x minus 1. And then the bottom, it's a cubic function, but there is an x in common to everyone. So I'm going to go ahead and recopy it here. X cubed plus x squared minus 2x. First thing I'm going to do is factor out the GCF of which is x. That leaves behind x squared plus x minus 2. Okay, don't lose that factor. That's going to be important. Okay, now I'm ready to factor this quadratic. Two numbers that multiply to -2 but add to 1. It's +2 and -1. Okay, so that's how the bottom factors. Okay, we've got an x plus 2, and an x minus 1. 3 factors on bottom. Okay, once again, we see a common factor, x minus 1. Okay, before I do anything else, I know that means there's a hole where x minus 1 equals 0. Whatever you cross off, go ahead and set it equal to 0. Add 1 to both sides, and so we know the x-coordinate of the hole is 1. Okay, now we need to write down the simplified form. Okay, the top is just an x plus 1. And the bottom still has the x and the x plus 2. So still have 2 factors on bottom. Cross off the original, we're never going back. Okay, and so now we can plug that 1 into that, which is x plus 1 on top over x times x plus 2. And so we're putting a 1 there, a 1 there, and a 1 there. 1 plus 1 is 2. 1 plus 2 is 3. Times 1 is 3. So 2/3 is the y-coordinate. You always plug the x coordinate of the whole into the simplified form. Okay, and so now that we have the whole, we can plot it 1, 2/3. So that's right about there. It's an open circle right there. Okay, now we are ready to find the vertical asymptote by setting the bottom equal to 0. So with this x, set it equal to 0, you just get x equals 0 as one of your vertical asymptotes. Set that equal to 0, you get -2 as your other vertical asymptote. Okay, and so we have x equals 0, which is the y-axis, which explains why we didn't have a y-intercept, because there was a vertical asymptote right there. Then we also have one at x equals -2. So we're going to have a really narrow piece of our function in between these two red lines. Okay, the other thing we need to find is the x-intercepts by setting the top equal to 0. If you set the top equal to 0, you end up getting x equals -1. Remember, that's an ordered pair. -1, 0. It's right there between our branches. That's nice, gives us a point. All right, and so for your domain, we have 3 restrictions. We have 2 vertical asymptotes and a whole. So looking at this original, we find the domain restrictions the same way we did from the very beginning. And so our domain, x cannot equal 0, x cannot equal -2, and x cannot equal +1. If we're going for interval notation, we've got to skip over all 3 values. So that's going to be -infinity to -2, pick back up at -2 and go to 0, pick back up at 0 and go to 1, pick back up at 1 and go to infinity. So 4 different intervals, because we have to skip over 2 vertical asymptotes and a whole. All right, and so this is the most complicated thing you would ever possibly have to graph. And so because there's a whole, I know that you can treat it like a point. And so the function is going to go through it, and it has to obey this red asymptote and this green asymptote. So I already have enough information to put this black piece of the graph right here. I know there's not going to be anything else down here because it still passes the vertical line test. Okay, I'm not sure what this middle piece is doing. Okay, it could be going up to make this S shape. It could be making a quadratic shape. We're going to have to plug in -1/2 and -3/2 in order to find out what's happening to this function. We're also going to have to plug in something over here. And so since this is at -2, we're going to have to plug in -3. Okay, and so I'm going to plug in x equals -1/2. I'm going to plug in x equals -3/2 to be right here. Then I'm also going to plug in x equals -3 for the last branch over here, okay? And so these two are for the middle branch, okay? So sticking with the middle, the simplified form, we're going to plug those into x plus 1, so -1/2 plus 1, and then on bottom, -1/2, -1/2, plus 2. There's 3 places to replace that x value with. Okay, -1/2 plus 1 is just 1/2. -1/2 plus 2 is 3/2 times the -1/2. Okay, so I have a 1/2 on top, and then on bottom, I have a -3/4, which is the same as 1/2 times -4/3, which is -4/6, which is negative 2/3. And you'll have your calculator too. Sorry, I was off the screen. Okay, so negative 1/2, negative 2/3 is a point on my graph. So that would be like right here. So I know that this function is going down towards this asymptote. Okay, now I'm going to plug in the negative 3/2. Okay, and so plugging it into 3 places. We're plugging it in here, here, and here. Okay, negative 3/2 plus 1 is negative 1/2. Negative 3/2 plus 2 is positive 1/2. Okay, so that gives me a negative 1/2. Gosh, I'm off the screen. Negative 1/2 on top, and then a negative 3/4 on bottom, which is the same as negative 1/2 times negative 4/3, which is positive 4/6, which is 2/3, positive 2/3. And so I know I have the point negative 3/2, comma, 2/3, positive 2/3. Okay, so on my graph, it's positive, like right there, just before the 1. And so now I know it's going up. And so that middle branch makes an S shape. Okay, and then now for this last branch, I'm plugging in negative 3. Okay, so these two were for the middle branch. This negative 3 here is for the last branch. Okay, so on top we're adding 1, on bottom, okay, so the negative 3 goes here, here, just following this formula, and here. So negative 3 plus 1 is negative 2. Negative 3 plus 2 is negative 1. So on bottom I have a negative 2. On bottom I have a positive 3. Okay, and so I know I have the point negative 3, negative 2/3. Okay, so negative 3, negative 2/3 is right here. And so now I know that this has to be going down towards the red because it can't cross that green. Otherwise, I would have an x-intercept. And then it doesn't cross the green here. Okay, so there's our 3 branches. And again, this is the hardest thing you would have to graph. And you can try to graph these in your calculator. Your calculator tends to freak out when you start having asymptotes. And so you're going to see some really weird things in your graph. When you have holes, asymptotes, your calculators don't really know how to handle these that well. And so that's why it's so good that we can find this information and then be able to interpret what that would look like on our graph. Okay, so in summary, find your y things first, factor and simplify. Whatever you cross off, set it equal to 0 to find the whole. And then working with the simplified form, you can do steps 4 and 5. Okay.